And this idea that we've been using with spaces for our decisions and number of choices in the spaces is called the fundamental counting principle. Now, in words, the fundamental counting principle looks like this. If there are n1 different objects in one set and n2 different objects in a second set, then the number of ways of choosing one item from each set is n1 times n2. Now that's in words. What we've been doing for this is we have been drawing a space for each decision. So space 1 represents decision number 1, and then decision number 2, and then decision number 3. And then within those spaces, the number that you put is your number of choices. So how many choices do I have for decision number 1? How many choices do I have for decision number 2? How many choices do I have for decision number 3? And so on. And then we multiply all of those numbers together to count the total number of options possible. So for example, if I wanted to figure out all of the different outfits I could wear for school. And when you see me up at the front, you see me wearing a shirt, a pair of pants, and shoes. So if I'm just worried about that, right now you can't tell that I have one pink sock and one yellow sock on because my pants are long enough. Okay, so we're just worried about shoes, pants, and shirt. Has anybody noticed the pink and yellow sock all year? No? Okay. So I have 3 decisions to make. Right? First, I have to figure out which shoes I'm going to wear. Well, I probably wouldn't put those on first. Maybe I'd probably put my pants and shirt on first before I put my shoes on. So I go to my closet, and how many pairs of pants do I have? Because that would be my number of choices. Right? If I allow all pairs of pants, including sweatpants, then I probably have, I don't know, probably 14 pairs of pants at home. Lots of pants. Now, if I restrict it only to my collared shirts, long shirts, and long-sleeved and short-sleeved, if I think of my closet, I have too many shirts right now. I probably have close to 30 pairs of shirts. And then I go to my shoes, and if there's no restrictions on shoes, then I've got like my indoor court shoes, I've got my black dress shoes, my brown dress shoes, my green dress shoes, I've got couple gray pairs of casual shoes, my soccer cleats, my indoor soccer shoes, probably have like 11 pairs of shoes because I never throw them away. My feet have stopped growing many years ago. And so if I want to figure out, well, how many different pairs of outfits could I have? Wow, this is a big number. Let's see, what would that be? Someone check that? Is that right? If you multiply that all together? Yeah? Okay. 4,000. So I could come to school for 4,620 days in a row and never have to appear in the same outfit again. It would be different every day. Like tomorrow, it's just random. Happen to have my nicest long sleeve dress shirt, sweatpants, and soccer cleats. Right? Again, with the one yellow sock, one pink sock. But that doesn't come into play. I mean, we add socks to this and there's even more outfits possible. But this is the fundamental counting principle. And we counted this very quickly, right? If I showed you the different, if I listed them and I said, could you list all the different outfits I could wear? That would take a very long time. The tree diagram would be also not very nice because you'd have 14 branches and then off each of those 14 branches 30 branches and off each of those 30 branches 11 branches and you'd have, oh, there's 4,620 in the end. Okay, there's a lot of different outfits, but this shows us that the fundamental counting principle can allow us to count things really quickly, big numbers really quickly. So if we go to example number 2 here, One of the places that the fundamental counting principle is very useful is for counting possibilities. Like we're going to look at how many passwords are possible. And the more passwords that are possible, the harder it is for you to guess what my password would be, right? When we look at license plates, they use the fundamental counting principle to determine how many license plates can we make in Manitoba. Why is it that Ontario has one more letter in their license plates than we do? That's because they ran out. They ran out of license plates, so they had to add an extra letter. How many more license plates does that make for them? And so all of this is based on this idea of the fundamental counting principle. So for this online bank account, you have 2 letters followed by 5 digits. So 7 decisions need to be made. And often what we'll do is we'll just briefly describe what our decisions are by some sort of word or code underneath. So I'm going to use L for letter and D for digits. In the English language, how many letters are there? "26. Nice. So you'd have 26 choices and 26 choices for your letters there. And then numbers in the English language. How many numbers are there? 9 plus 0, 10. So 10, 10, 10, 10, 10. Multiply this out. Again, if someone could check my mental math. I think that's good. Yes? And so with that many possibilities, it would be hard for me to guess your password. Well, for some of you, right? For some of you, I would just go, guess whose password I just guessed? So whose password? Yes, it's David's. Right? Some people do that with their password. They're like, I can't remember hard passwords, so I'll make it really easy. I'll just use my initials and 1, 2, 3, 4, 5. And then, sure enough, nothing makes you more happy when you get to a Wi-Fi and you're like, oh, it's a guest Wi-Fi. I wonder if their password is guest. And lots of times it is. And you can get into their password with 1 or 2 checks. Although now it's getting harder. People are changing them up so you can't guess them as easily. Okay, so questions for practice on this one. And there are lots of questions because each one's worded just a little bit differently. Again, you do have to think. I even put an asterisk beside the last one because it is an interesting one to think about.